Hello everyone, welcome to my channel. So today we are going to do Leetcode, one of the question which is mentioned in blind 75 list, and this is the sheet which we are following. So here you can see that we have already solved a lot of questions which are there, but today we will be solving the question of matrix. So here you can see these all questions and their links are there, and some of them are left which we will be going ahead and solving all of them. And for matrix topic, basically we have already covered 1, 2 and 3. These 3 questions are already done and uploaded on the YouTube channel, and you can follow this link. I'll share that. I'll show you. So basically this is the playlist blind 75, and in this already 53 videos are already uploaded, so you can see that. So you can follow this playlist, and each and every question which is there, links are provided here, and the question corresponding question link, everything is there. So regarding metrics, so we have already covered 3 questions out of 4 which are present in this list. So now today we will be completing this last question, that is this spiral matrix, and apart from that this set matrix zeros and rotate image and word search, all these are already covered and uploaded. That's why these links are there. So without any ado, let's start. So here we are given with the spiral matrix. So given an m cross n matrix, not spiral matrix, basically a matrix is given to us and we need to return a spiral matrix. So return all the elements of the matrix in the spiral order. And spiral order here refers to, before we go ahead, first thing is that we'll check for the constraint and whatever possible solution could be there, then implementation part with possible edge cases, and then time complexity and space complexity if it could be further optimized. Now here if we see the constraint which is there, it is up to 10, means basically 10 cross 10 matrix could be there at max, and the elements which are present in that matrix, that could go from minus 100 till 100. Although we are not concerned with the values, we are just concerned with what will be the length and breadth of that matrix, means number of rows and number of columns of that matrix, which is at max up to 10 into 10. That simply means that if we even go ahead with order of n square solution, then how it would be that, because 10 and when we go ahead with n square solution, then it would be 10 raised to 10, right, 10 square, and that would be the thing. And here n will be we are referring to the row count or column count. That's the thing. And anyhow, when we are going ahead with a solution row into column, which will be n into m, and if we say that this particular matrix which is there, it will be having equal number of rows, then n will be equals to n, right? Then it will become n square solution, and anyhow this n square solution will completely suffice. That is the thing, because it can at max go till 10 only. So now with constraints we are okay, means time complexity wise we are okay. We want to take another data structure or something on that, will be completely dependent upon what solution we are going ahead. Now comes the part, let us first check for the possible cases, means the example test cases which are given to us, and how we are required to deduce solution for the same. Now the thing is, see here the things are that, first thing, that we are going in the horizontal direction from, if we say this as left and this as right, this particular top and this particular bottom, right? So first we are going from left to right, that is what we can see, right? Then second direction which we can see here is that we are going from top to bottom. Basically here first row is constant and the column is changing, column is variable, right? And here if we see, here rows are variable and column is constant. That is what we can see. And all these things which are going, these are going like from minus to positive, and that anyhow Okay, let us don't take that for time being. Minus positive, let us don't take. Then the third direction which we can see is, then it is going here, means completely opposite of the first direction, right? Means it is going from basically right to left, where again the same things are there. Rows are constant, not rows, but the row is constant, and columns that are variable, means column would be changing, and the fourth direction, that would be negation of the top bottom only, because now we are required to go here. This is the first round, right? But another things which we can observe here is, basically this question is a complete observation based question, simplest question and observation based question. Now here if you see, in the first direction which was there, so anyhow we were going from left to right, everything was as it is, whatever the length of that particular row was, means basically number of columns were as it is. And when we got to next direction, there also same. When we got to another direction, then also same. But then when we got to upward direction, then here we can see that this was not there and this was also not there, right? So basically here we need to deduce, basically deduct the count. That is the thing. Basically if we see to the same, when we are going from bottom to top, right, we are not required to even go completely to the top. We are required to go somewhat one minus from that top. That is the thing. And when we will be going again to this direction, here also earlier itself we could have reduced the right at this point, so that this column, means this column is not there, means it is not coming into picture. So now here the thing is that here we are required to reduce the right. Here we are, when we are going to bottom, if we see here, right, when it came here, okay, 5, right, if we were having some more, means some more columns would be there and it would be going down, right, again it won't go to exactly that much length or breadth the way it was there earlier, right? So that's why what would be the destination at that particular, in that particular direction, that we need to reduce, so that next time when it comes into picture again, so that it don't touches that particular block, that particular cell. So that's why here also bottom would be reduced. Here now the thing is that destination is left, right, so left would be reduced, and here the destination is top, right, so top would be reduced. So in each direction we would be required to do that also. This is also one of the observation here, means the first thing is these observation, that which one is constant, which one is variable. Second observation is that we need to reduce whatever directions we are taking, left, right, bottom, top, these variables we need to reduce them, and when we need to reduce them, that is also one thing. So that's why in each of the direction one of the variable would be reduced. Now the third thing which is there, that we need to see to it that when we are going in a particular direction, then what would be incremented, what would be decremented, so that we can go ahead towards that particular direction. So in that manner only we will be coding the same. So now the thing is that these first two things and third thing would be about the direction, that when we need to go just negative of what it was there before, and how we need to code that. So then only we will be able to go ahead and code it. And this overall, we won't be taking any extra space, we will be just traversing the previous one, and whatever the answer which is there, that we need to return. For that purpose we will be using, because anyhow this is required to be returned in the form of vector, so for that purpose only we will be using the extra space. Apart from that we won't be using any space. So in all that context, the time complexity here is order of n square, because we are required to traverse this n square, this n into n matrix which is there, and the space complexity which would be there, that would be order of 1. But if we take into consideration the vector in which we are basically pushing our answer, if that is the case, then it would be order of n square again, because order of n square elements are there in total. That's the thing. So this would be a final time complexity and space complexity, and this is the, like, even after observation and so on, and even on the brute force one also, this is the most optimized solution. So now let us go ahead with the coding part. So now, as per what we had earlier deduced, um, means after the observation, what all we were doing, right? So as per that, now either you can, okay, let me pause the video and draw that again so that I can show you. Okay, there was one mistake last time when I was explaining. Actually, the thing is, see, when we are going in this particular direction, right? So next time what we want is that we shouldn't be there in this column, we should be there at this particular column, right? So that's why we would be required to go this down, right? So that's why we will be incrementing top rather than the decrementing or incrementing of the destination. So now here, when we are going from top to bottom, right, the next time what we will, means when we will be going top to bottom again next time, at that point what we will be required, we will be required that a right pointer which is there, that is shifted towards this, means it shouldn't come again on this point, mean this particular column, right? So that's why we will be reducing right pointer which we will be taking. And why we are reducing rather than incrementing, because we know that right is starting from here, and if we will be incrementing it, it will go out of bound. So that's why we are required to reduce it. And same logic goes for the other two direction. When we are going from right to bottom, means at this point, the next time what we will want, we'll want that the direction should start from one row above, right? So that's why we will be decrementing the bottom. And same thing goes from for the bottom to top. When we are going here, next time we will be wanting that our bottom to top direction should go just one row ahead, and that's why we will be incrementing the left pointer. So these were the few mistakes which I had done in explanation earlier, but now after when I was drawing and reanalyzing, so yeah, I figured out that it should be something like this. So now after this observation, now we need to code this particular as it is, the way we are observing. So let us start with the coding part. So here, that's why I have kept this particular drawing sideways, and in the interviews also you can do the same, because interview won't mind that your drawings are there and you are coding. It's completely fine. So now, and another thing, during interviews we need to basically think about the fact that we should use all the variables which are like production ready variables, not a b c l or something like that. So that also have points, right? So accordingly we will be using variables also. So now our row equals to matrix dot size, this would be a row, and the column which is there, that would be matrix of 0 dot size, that will give us the number of columns. So now the next thing is that from this explanation you would have deduced that we will be using a 4-pointer approach here. I don't know if 4-pointer approach exists or not exist, but here we are using 4 pointers which are from top to bottom, left to right, and accordingly means modifying those pointers only we will be getting our answer. So here we can say it as 4-pointer approach because anyhow we are using 4 pointers. So now the next thing which would be there, int left equals to 0, then right equals to basically the column which is there -1. This would be our left and right pointers, and then top and bottom pointers, we will be, top would be at 0 and bottom would be at basically row -1. So these are at top to right, top to bottom, And then we will be using one variable direction. So this direction, the way we are having these direction, 4 direction, so as per those 4 direction we will be having that 4 cases, that 4 directions are there, and accordingly we need to move our pointers. So that is what we need to code here. So now at the starting our direction would be 1, because anyhow at the start we are required to go from left to right. And we will be using one vector answer, because we are going to fill this vector and return this, because our return type is vector of int. That's the case. Now the next thing which is there, we need to start coding. And for coding we need to keep a check that left is less than right and top is less than bottom. If these conditions satisfied, then only we will be proceeding with going ahead. So these are our main conditions. And then top less than bottom means basically there could be a case that both of them are equal, but yeah, this is the case which is required. Now I told that there are 4 cases, so we can use those rather than using if else condition, because a lot of time it's better to use cases rather than using if else condition. So here we will be using switch cases. Even if you're coding in Java or any other language, we have these, right? So we can just directly use that. And the variable direction which I had taken earlier, we are going to use that, and accordingly we will create our cases. So case 1, that is the first direction. So for that, what we are required to do is now, so for int I equals to, we will start from the left, and then I less than right, I less than right, I plus plus. This would be the case, right? We are going from left to right, and then we need to push into our answer. Here the thing would be that what all are constant and what all are variable. So we can see that row is constant, right? So that's why we will take the matrix and our row is constant. At this point, what would be the row value? That will be because of the top variable, right? So our row is constant and our column is variable. So I would be for that. So this is how we will be traversing this particular direction. Okay, now traversal done. But there was one more observation, that we need to increment the top, and that is what we will be doing now. So okay, so we will be incrementing our top, right? We have done that, top is incremented. Now what's next? When we will exit out from this case, right, this will hold true, but it will again go to direction 1 only. And if it don't goes to direction 1, so for that we need to change the direction. So we will be changing the direction to direction 2, and that is what we will be doing. So we will be putting direction equals to 2. So that would be the case here, and then we will break out of this particular case. Now we need to write our case 2. So our case 2 which is there, so things would be similar only, but now means similar in this direction, that these 3 things we need to do. But the things would be that what is constant, what is variable, all those things we need to do. So that would be the thing here. So now for int I equals to top, I less than bottom, and I plus plus. Now what all are variable? Row is variable, so our I would be at row, and constant is column, and column, okay, let us first write answer dot pushback, then matrix of, so our row is constant, row is variable, so that's why we will be writing I here. And now the column, so here the column, the first ones which are there, that is because of top and bottom. The second ones are because of left and right. So here which one would be having this last column's value, right? So that would be because of right, so that's why we will be putting right here. So now here And now the next thing which would be there, what we need to reduce or increase, right? So next time when we are again in this direction, we want it to start from here, right? So that's why we will be reducing right. And the next thing is about changing the direction. So we need third direction, so that would be the thing. And then we need to break. So now case 3, again same things, we need to start for int I equals to, now we need to reverse the directions, right? Earlier it was from left to right, now it's right to left. So now right I should be greater than equals to left, and now I minus minus. Now same answer dot pushback matrix. Now here the things are, again the row is constant at this particular point, but here the row would be determined by bottom rather than top, because we are starting from the last. And then we are having, now next time when it comes into picture, means in this direction, what we want, it should start from one above, right? So that's why here we will be basically decreasing the bottom and then changing the direction to 4, and then we need to break out of the this case, and then now we need to write the case 4. So for the case 4, for int I equals to, again same things, this one, but direction would be reversed. Bottom I greater than equals to top, and then I minus minus, and then we need to do answer dot pushback and matrix of, here basically the variable part would be row and the column would be constant, but now here the column is required because of left, because we are starting from the left direction. Now what we need to reduce, when our it is at this point and next time we want to start from here, so we will be reducing the left direction, and then we need to change the direction equals to 1, and then we need to break out of this particular case. So this is the code which is like production ready, and if you will write something like this, not something like this, basically like this, you will, interview would be basically impressed after this. And now this was all for this particular, if we run this, where is runtime error? Why runtime error? Let me check, something I have done wrong. Direction 1 left less than, okay, less than equals to, right? Actually in everyone, means in every we need to have that is one of the thing. Now top and all those things are good to go, direction changed, and top bottom, and this would be I, right minus minus, direction 3 fine, direction 4, and this direction 1, bottom, oh this is the main reason actually why left minus minus, it should be left plus plus, because we are going here. Now there shouldn't be any runtime error, and if we submit it, yeah, this got accepted, beats 100%, but I guess a lot of people hadn't solved this question, that's why there is not much enough data. And if we check, okay, anyhow we know that what is the time complexity and space complexity. So fine, this was all for this particular video. If you have any doubt, you could comment that down, and if you think that this particular question could have been solved with any other approach also, or you are thinking like why we can't use this approach or something like that, that also you can comment. So this was all, thank you.